we're asking ourselves, do we reflect the same? Do we display the character of God as he instructed of us from the book of Galatians? And hence, it's just a moment to take a break, reflect on your life, reflect on that inside of you, and assess to the extent to which we are in line with God's character. That applies also to myself, that in each and every moment, it's a moment of self-reflection and assessing ourselves in terms of how we are, even in the context of the fruit of the Holy Spirit. So I know we are also approaching Easter season, and I think it's also a good moment for us as we look forward to the celebrations. Think about that. Think about such things as well. So as I leave that for you as well to think about, even in terms of the content, the things we do in statistics, in any other unit, it's always good to remember that the character we take in the classroom, in our own work, should also be reflective of the same, so that when we come out of each and every session, we come out with these fruits, which others will also see in us. And as we conduct ourselves in our day-to-day lives, then even as we better ourselves through careers, through programs like these ones, we become even more influential, even out there. So I just want you to think about that, even as we start the session this evening. And so we pray, and then we begin. Father, we thank you for this time that you've enabled us to meet once more. I want to thank you for everything you've done for us in the past. We thank you for the week that has gone from the time we met as a class. We want to reflect on the goodness that you've given us as well, even to display inside of us. We thank you even for the reminder that you've given us today to reflect on the fruit of the Holy Spirit, that even as we conduct our lives in each and every occasion, we're always reminded to reflect the character of God in us. Help us, Heavenly Father, with the help of Holy Spirit, so that we can truly reflect and be that which you expect us to be. I want to thank you for this session you're having this evening, that you guide us and give us knowledge, wisdom, and understanding of each and every concept and task and activity for the evening. Be with us as we engage together, for we pray in Jesus' name. Hallelujah. Amen. Thank you very much. I think we can begin. Then we see what we have to do today. Yeah, so I think I have asked you to, as we begin the lesson, try to get into your D online, download the material for the day, which I think it has uploaded 3 documents in there. We have some lecture slides that we shall run through. We shall also have an aside attachment to the same, and some sample data set, which I have also shared for the lesson today.
Sorry, Malimo, I've not found it. It's just taking me to the training.
The training.
I've not found it. It is the 9th week, isn't it?
7, look, I think week 7, under hypothesis testing. Okay. Just go to week 7. Okay. Week 7, I think. Please get all of that material right there. I just want to have confirmations. Under week 7, we have content on hypothesis testing, which I believe will also run through this week 9. After this, I want to think that we will only look at 2 other major topics. One on correlation analysis, and the last one on regression models. So those 2 when covered, then blended with what we're going to do today, then I want to assume that the content will have been covered, and different items that cut across descriptive statistics to inferential statistics to some bit of practicals that will help us to reflect on a good journey of statistics. It's my hope that much as we not have covered everything, we will have had a good exposure to numbers and working with them manually, and also even generating using with the aid of some of the tools we have access to, including Excel and even other software. Just to confirm that we have had access to the same. And then the second thing I'll also expect you to have access to is the tool that I shared 2 weeks ago, which is Stata 11. Please, if you would want to work with us at the same time, I would appreciate that you also have it somewhere. And that is the reason why I've given you a very huge data set, which is different from that we've been working with. In the past, I've been giving you just information regarding 2-3 variables and a few numbers there. So the data set I've shared with you today regards some hypothetical data on some key variables, which we believe we can walk through today, and we will be able, for the sake of understanding hypothesis testing. So the objective for the main approach for the day is largely practical. So we will take a practical approach to the discussions that are going to take place. Of course, I'll begin with some very brief introductory remarks on hypothesis testing, and we will have some few questions on how that is going to even help us for research purposes. I want to believe that as a student of statistics, inferential statistics can be complete with the mechanics that we did for the last 2 weeks, including confidence interval construction and even the issue of distribution. Then that is useful, but it's also good for us to take it up a little bit further to understanding hypothesis testing, to the extent that when you collect your own data in the field, you're able to process it yourself and talk about numbers, including this high level inferential statistics in the name of hypothesis testing. So I want to just ask that as we begin the session, as I share my screen, just want to take note of the things that I have asked you to do today. First things first, let's just see it. Please confirm that my screen is up and running.
Yes, it is.
Good. Now, so the things that for the rest of us who are going to follow the discussion the day, I had shared a folder named S11 or Stata 11. And I think the last time we met during class, I'd asked you to just, you don't have to install anything. What you need to just to open up the folder itself. And it has a few files. It has and quite a number of tools in there. And what we will be working with is simply the last file down there, Stata SE, which is the application you just need to double click and we are good to go. So it can handle a few variables. But bear in mind that this is just this is not the latest version of Stata, but it is useful. It is the same in terms of it will serve the purpose for the unit. And after all, you can still as well use this one even for your own research, should you want to learn some of the things. So at some point, I'll ask you to open that. I've also shared some sample data set, which is in Excel. I just want to describe the variables you're seeing here. This is the name of the data set is called student achievements. So what I've done is just to get some numbers representing 200 students. So when you look through up to the last observation down there, you see we are up to 201, but of course you can remove the first row. That means that makes 200. So these are a sample of 200 students who sat high school national examination for a representative here, but we've just sampled 200 of them, and we've recorded their overall mean score out of 12. So we record their data in terms of their mean score. We also ask them what is the household size, their family size, how many they are at home. They will indicate. We also record their gender. Then we also indicate, just a moment. Sorry, I think I will have to let's not work with the last that variable there for now. I think I did not I mismatched that. Apologies for that, but I would like you to drop this variable because I'm seeing that it's not matching with our agenda there. Yeah, so we will drop this variable. I've just noticed that. We have another variable called the region. So this is just 3 regions sampled, north, west, and south. So those are the 3 regions where the particular student comes from. We've also recorded their average years of education for their parents, how much they've spent, how many years of education they have, ranging from 2, 3 going upwards, including others with more than 1 degree or even more than that. So allow me to ask you to drop this column by just highlighting with that arrow there, right click and then delete, because you will not use that for now, because I noticed that I think I copied it wrongly. So let's drop that for now. Then we have this is the scores, mean scores for the languages. That is the English and the Kiswahili, the average mean scores for languages. So these about student achievements and a few data sets around maybe how the students have fared and a few of their characteristics. So we have that kind of data set which we think we can just use for, we demonstrate what we intend to do under hypothesis testing today. So I wanted that to be described so that we understand what type of data and the questions we're going to address today. So having said that, then I've also shared with you 2 other documents. Let me just get hold of the other one. This is parametric. Just opening up as well. So I've shared 2 other PDF documents. One, hypothesis testing parametric tests. And then this is the lecture slides. These are 16 slides, which I think we can just run through very quickly. But I know that principles of hypothesis testing might not be very new to a significant number of us. So in terms of the approach for the day, I have really avoided to go mechanical because I wouldn't want us to just go calculating and looking through tables and the like. That knowledge you already have gotten in the other 2 chapters. So I want to do it now practically, including data set that you can as well generate from the field. So some of you could go to the field from your questionnaire. You've asked your respondents different questions depending on the research question. Then you've organized your data in such a way that it's now admissible into a software. So one of such is through Excel, as you can see. You'll never, I know when you go to collect data using questionnaire, you can never get very nicely arranged data like the one I've showed you, but it's part of the skills to reorganize and code and the rest. Now, having said that, let's just run through the basics of hypothesis testing first of all, and then we come back to data. So I've just started here with some context to just understand where we're going to in this topic. And I've just given a case in there that suppose you are the principal of one of the schools, and from the recently released end of year national examination, you hear a few claims that are being projected out there that, for example, the mean score for students in your county is 6.5 out of a possible 12. So you hear such kind of reports given out there. The proportion of students or schools in your county with a mean of 7.7 is only 20%. You know, So nationally, the girl child had outperformed the boy child in terms of the scores. This is where we are. So those are just questions that I just posed, but I think you can as well reflect and look at more than that. Well, these are things that they always keep telling us about. But you can contextualize in any other research context, whether you're in political economy, whether you're doing a study on health outcomes, and many other cases. You can as well contextualize your questions, which will reflect issues that needs to be taken beyond or taken up beyond just the face value. So it is possible to really listen to such sentiments and then agree with them. But because you are a statistician, you would always want to ask questions and say, well, if that is the case, then how can we validate those claims? How valid are those claims? It can only be validated if we subjected this to the process of hypothesis testing, which implies that we run through the whole process of research. Collect data. Someone asked me, how did you sample? So you must also ensure that you have also sampled your data correctly. From here, you can be able to now use appropriate statistical procedures to validate these claims. And that is the whole point where we do hypothesis testing. So I would like to encourage you beyond, as you do your research, as you collect data in the field, beyond just giving us descriptive statistics, I want to challenge you to take it a bit higher and apply hypothesis testing to enrich the nature of the analysis that you perform in those research articles. So it's just one thing to tell us 50% of your respondents viewed education as impacting their livelihoods positively. But you are not telling us the differences within the different the heterogeneous samples that we are talking about. Perhaps the problem, the results could have been because you've sampled maybe from a wider region that believes so, but then you are not also singling out that there could be differences in views between different groups. So if that is the case, you can then analyze and say, well, is the same view held between the diverse groups? If you have a way in which you can classify your audiences or respondents, it's a useful way of now taking the analysis higher to inferential statistics. So at your level, surely at the master's level, we should be able to go beyond descriptives. So having said that, then what we are dealing with right now is simply the statistical procedures that will enable us to talk about the population with some degree of confidence. That means you make inferences about what it is. So before someone says that overall the counties in the urban centers performed better than those in other regions, then it has to be something that will be widely accepted by the population. And so it can only happen when you apply appropriate statistical procedure through and then filter through the data you've collected, and then now come up with a validation of those claims. So it can be something about, it's mainly quantitative measures, because in the end, when you say hypothesis testing, it is quantifiable, it is measurable. And so you would want to have a way in which you can quantify your claim. And then because we are dealing with hypothesis testing, then we must attach some probability value to we must attach some probability to the claim. And because we are talking about probability, then the quantitative aspect comes in. So definitely most of you have come across the null hypothesis and the alternative hypothesis. And I think that is an area that I think you've covered quite a lot in research. So we often begin with this null hypothesis, or rather a statement that could be widely believed, like the one I've just given you. If that is what is seen in the national statistics, then you can take it up as your null. or if theory proposes a certain relationship, then it becomes your null hypothesis. In other words, this null hypothesis is simply an educated guess, or rather an educated claim about a certain a context. So educated in the sense that it has to be in one way or the other, widely believed, or there's some basis behind the same. So I'm sure you know about the notation H0 for the null hypothesis, and then alternative, the H1 or HA, which is what we expect to do. So at the end of it all, we want to collect the data and then assess whether the probability that you made the right claim could be accepted. So in a nutshell, the null hypothesis describes what it is about the population which you're trying to characterize. And so if you get evidence in favor of your null hypothesis, in statistics we say that we do not reject it. So if from your sample evidence you find that indeed your claim is justified, then the appropriate language there is that we found evidence from the data that we should not or will not reject the null hypothesis. So it is all about the null hypothesis. It can never be about the alternative. So when you go to the field, you are testing the null, not the alternative, because the null hypothesis is what you believe holds about the population. So you don't go and test the other one. The alternative is just there for you to be able to perhaps have a fallback option should you reject the null. So if you reject the null, then what are you concluding? You conclude the alternative. In most cases, when it comes to data that you have collected, typically we state the null hypothesis in the negative sense. In other words, you want to say that the status quo remains. So you want to go with what you believe is the null hypothesis. And so many times you find that null hypothesis is stated in the negative sense. For example, there's no difference in the population mean. There's no effect of one thing or the other. So that becomes your null, because we believe that you've made a good educated guess to the extent that it is a null hypothesis. So you must begin somewhere so that you can go and test that particular null. So that is the story behind the null and the alternative. So I've just given you another example in here, which you could also contextualize for those in business. That suppose the share price of some 30 listed companies in the stock market rose by 5% every year on average for the last 6 years. So with a standard deviation of 2%. So if that has been the trend for the last 5 years, then you can clearly say that the prediction for the next year should not be different from 5. So that already forms a null hypothesis if you want to assess whether your next year's predictions will be different from 5. So the claim there is based on some reason. The reason is because you've looked at past trends. So you don't just develop null hypothesis from the skies or the blues. There could be some reasoning behind the same. So having said that, the alternative hypothesis there, which is now the HA or H1, can now be stated in 1 or 3 ways. 1, 2, or 3 ways. So it will now depend, it will be dependent on what the researcher feels or opts for if the null is rejected. So later on, you will see that when you have a null hypothesis which says that the price will be 5%, then there will be 3 ways in which you can conclude in the opposite. For example, we could say one of the alternative ways is the price increases will be different from 5%. Another one could be the price increase will be smaller than 5%. And then the last one will be, it will be higher than 5%. So there will be all those options, which now is open for the researcher to choose. So for the alternative, it is left for the researcher to interpret from the data that you have given. or from the hypotheses, the null hypotheses that have been presented. So think about that as we even go into the mechanics and how to evaluate the same. I would like to see any or hear from any member of the floor if they want to add anything with regard to the null and alternative. Only one person so that we don't stretch it further. I'm just trying to borrow from your research classes. Let me have a contribution from one of us. Before I sample, I can easily sample the middle name in the group. Yes. Any respondent? Moline, or if we proceed? Moline or Kedogo? One of the two. Anything you want to add about alternative, null, and the rest?
Hello, Dr. I'm still trying to internalize the concept of null and alternative.
Okay, then you are passing to Kedogo. In other words, let's hear. Proceed. Even with your own example, context. Because when you go to hypothesis testing, you should have an hypothesis. You just can't go and test or run a test without exactly knowing where you're coming from. Okay. Chris, any submissions? I want someone to think of another example and see if you could be able to develop or come up with a null hypothesis. Especially in the fields of your specialization. Any medical researcher? Yes, Jane Amisi. Any?
I'm just trying. I'm trying to formulate something. Yeah.
Okay.
Probably. You have. I don't know whether to consider a school or. Okay, performance in a particular subject. Yeah. I'll say maybe the performance in maths. In a given school where they've registered 100 candidates. So the mean rising annually by around maybe 3%.
Okay.
So with a standard deviation of 1.2%. So if we use that, so I was imagining we're trying to test whether in the coming year the mean will also raise by that 3%.
By that margin?
By the same margin, yeah.
Good. Okay. Thank you. Good contribution. Let's make it now. That's a good one. So think of your math performance. You could as well reflect on your performance of math scores. You can even look at all the streams in the school.
Yeah.
For the last couple of years, 3-4 years. Then you see the changes and say, for example, there's always a positive change of 0.01 points. Yeah, so there's always an increase of 0.01 for the last 3 years. So you want to now predict and say, well, on average, that could be a starting point for the null hypothesis that the math performance in this school improves by 0.01 points. Good, let's move on. Thank you. I want another case study on health. Anyone in health? Anyone in financials? Anyone in business? So that we look at different variety of cases. Because this can only happen if you conceptualized a research. You think of your research area, you know, that some of us are trying to develop research topics and ideas in. I'm asking of you, if you are considering, for example, impact of immunization on health-related outcomes, you know, can you think of an hypothesis around there? You see, if you are in government, you look at financing, government financing different projects in education. You see, does government financing improve education outcomes in your region? So I'm opening up your mind so that as you have your research topics, don't just think beyond descriptives. Ask yourself, can I take it beyond that and talk about hypothesis testing? Good. Okay, thank you. One more person and then we can proceed. Because if you don't get the hypothesis aspect, then we might not achieve the end goal for the session today. Any other person? Francis, you're always contributing. And Taslin, let's hear the two of you, or one of you.
Thank you for the chance, Doctor.
You forward the chance to Taslin or Eugene. Taslin, are you there? Eugene, are you there? Cindy?
Doctor, yes, I'm here.
Yes. For us, which is your area of specialization, Cindy?
I'm a teacher.
You're a teacher. Let's go move to another person. Who is an health practitioner here? You know yourselves.
It's Madiang and he's absent.
Madiang is absent. Okay. A different area of expertise. I've talked about education already. Yeah, okay, fine. Let's proceed, and then I hope that as you go along, we're able to open up and think beyond, or beyond the concepts. Just think about the concepts that we are trying to work around. Where is Othello today? Is he in? Not yet. Yeah. So I want people to realize the significance of this topic, because if we don't see inferential statistics in research, at times we get a bit worried, so that we don't just read narratives and the stories and the descriptive. Descriptives are very good, yes. Beyond just the average, the mean, the graphs, and the standard deviation, this helps to enrich and give a different flavor to your analysis. So I'm encouraging you as we proceed. Hopefully, I'll come back for another round of questions and contributions before we even go into the depth of the topic. So when you have data like what we have here, the data I've given you in Excel, ideally that you can think about it as determinants of education achievements. You can have something like that. So what determines education achievements? Can I be able to have a prediction of the mean scores for the students in a certain context? Because I'm asking myself, is it useful for me to understand why certain schools score more or higher mean scores than others? So I want you to think about this as this being your main focus variable. So if I want to understand the education achievement, so I'll ask myself, how do I measure education achievements? One of the indicators is the maybe mean scores for the school or mean scores for every child. And so I'll ask and say, what determines the mean scores they get? Could it be because of the characteristics of their households? If there are so many in the home, does that affect their ability to concentrate? Will that affect the performance differently? If you are male, does it even matter? Or if you study in a mixed or mixed high school, does that affect your mean score? Region, is it important? Well, you could come from an arid area or from the urban areas. Does that imply that it has something to, it can influence your outcomes? If your guardian has some degree of education to a large extent, does that affect your performance in terms of your scores and the rest? Does the mastery of language correlate even with your overall? So you may find that in some contexts, schools that do better in the languages tend to also have similar scores on average. So it's possible to even use certain mean scores for certain subjects to just form an opinion about how the school will perform on average. So what we are doing here is actually proper research that as you collect data in the field and you process it, can it help you to form a story about your key area or your key variable, which in this case is your student achievement as measured by just one of the indicators, which is the mean score. But please know that there could be more other indicators for achievements for our students. Right. Now, having said that, with the knowledge that you have, then with your data, then beyond just describing and saying that the average score for the students for the students in this region, which is comprised of the North, the South, and West, is 7.5% or 7.5 marks. It is a good thing to mention that on average, the mean scores for the region is 7.5 out of 12. But it's not very useful because I'm not taking into account the differences that I'm seeing in the averages in the scores. There could be something. It does not also tell you about the disparities with regards to region, with regards to even gender and the like. And so that is why we do and hold some research to establish the fact and be able to make predictions about test scores. So we will use this data set for this topic on hypothesis testing and for correlation, the one for regression. And then ultimately, it will be a complete package. So when you go to do your research out there, you should have techniques to summarize your data into search, run through through any statistical tool, get results, and importantly, talk about it, which is what we will do at the end of it all. So having said that, I want to just take you through the process of hypothesis testing, but we will do both ways. This is the traditional approach, which we will not follow, which you may not necessarily follow in this particular lecture, but it forms the basis for what the software does. So these are just is a four-step procedure or process, which I've summarized in a compact manner. First of all, you must understand what it is that you are testing out there. For example, in the data set, the null hypothesis is what I'm looking for. For example, if someone says that the mean performance differs according to region, rather there's a difference in the mean scores of different students based on their region where the schools are situated, where they are located. So I'm interested in that variable and this other one for region. So the hypothesis is, in this case, remember noting that a null hypothesis is formed in the negative sense. Then I'll go out there and say there's no significant difference in the mean scores of students who studied in schools in different regions, in the 3 regions in this case. So that becomes the hypothesis you go out to test in the field. Secondly, you can as well say, well, you want to think that on average, this region, this bigger region divided into 3, the average score is 6.5 or 7.5. So you want to go and test whether is it indeed true for the entire county. This county has 3 regions, but because there are so many students in this county, thousands and thousands, you've only sampled 200, or believing that this 200 will give you an opinion about the entire county performance. So you go and now say in one of your null hypotheses that the mean performance, the mean score in the entire county is 7.5 marks or 7.5 points. So you can come up with very many different null hypotheses that you can now go out to test, including differences in gender, comparing the performances in the total versus the languages, or even with math and any other. So think about such. So the first thing is that you should know what you are testing, and you can come up with 1 or 2 for your research or for your research question. Then number 2, this is what we did in the lesson when we did normal distribution. We did not cover entirely. We did say z-test, the t-tests, and the rest. But we have to look at the data and see whether they conform to which distribution. If you remember in our meeting, we had about normal distribution, skewed to the left, and the rest. So this is the point in which you now make an assumption about the data that you have. For instance, if it fits a normal distribution, or if it fits a normal distribution with the t-test, then there are particular approaches that will be used to calculate those test statistics for you to be able to carry out the test itself. So for today, we shall demonstrate the data which fits a normal distribution, and therefore we shall introduce the t-test. So there's an f-test, which we shall talk about also at some point, and there's a chi-square test as well. So this now depends on the assumptions and also the nature of the data that you work with. So it's good to know whether it's normally distributed or not. A variable such as region, definitely you know it is not, because it has a different kind of thing. These are only 3 cases. It's either north, west, or south. But data such as this scores, household size, these ones with numbers, it is likely that they could fit a normal distribution, especially knowing that they are more than 40. If you recall what we did last time, as your number of observations tend and go beyond 40, there is a heavy possibility that the data is normally distributed. But if your sample size is smaller, then you know that you are not getting anywhere near normal distribution. And so unless you make those assumptions, then you are directed to a different type of test to conduct. This, as I skip this section, helps you to distinguish what we will refer to as parametric and non-parametric tests. Non-parametric tests. So there will be 2 categories I'll show in the next slide. Then mechanically, we would always compute a statistic, which is either a t-statistic or a chi-square statistic or an f-test statistic from the data, and then compare that with the critical values of 1%, 5%, or 10%. If you remember the last session on confidence interval, we were saying confidence interval of 95% confidence interval means you are talking about 5% level of significance. So this is the level of significance. So we are comparing whatever you gotten from the critical values that you get. But from there, then you can now see whether you want to reject or not. So this is the traditional way of doing it. You compute a test statistic, you compare with what we did last time on the Z statistic. For example, if you can remember what we did last time, at 5%, T statistic, T critical was 1.96, if you can think about that. So this gives you 1.96 on both ends. If it's a 1%, it's 2.58. If it's 10%, it's 1.64. So if you look at those things from the Z tables, those are the only critical values to work with. So you'll be comparing whatever you've gotten in your calculation with one of these, and then you make a decision, because in your distribution that you have drawn here, we know that this is your acceptance region. If your computed value falls around there, then you say that you are not going to reject the null hypothesis. You're going to, let me use the language of accept it. But otherwise, if it falls on the shaded region, it's rejection straight on. So you use that as a way of rejecting the null. Okay, like I told you, we are not going to do the mechanics. We will look at it practically. So there will be three ways, as I told you. It depends on the type of test you are going to conduct. We have what's called a two-tailed test, left-sided and the right-sided. The first one there is the two-tailed test, which you can see, because we're dividing the region into two separate parts, so that the 5% that you have will be 2.5% on one side and 2.5 on the other side. Otherwise, for the one-tailed test, we call this one up one-tailed test, either to the right or to the left, it will now be entire 5%. 5%. So this is dependent on what hypothesis you are working with. For example, if you say that the population mean is 12 against not 12. So here you are on either side. So you'll be either on the right or the left. Otherwise, you can do an upper tail test by considering the alternative being on the greater than 12 side, and then or it's either less or equal to 12, which now becomes your null. So your null is say your 12 is at most, your values is at most 12, meaning it's 12 and below. Or you can say it's at least 12, which means it's 12 and above. So it means that you must now do the alternative by looking at the other case. So these are special cases, but I know the most popular one is the first one, where we have the two-sided test. So we will not do the mechanics, but rather we will look at the p-value approach, which is now what we often apply, is the most summarized and straightforward approach, because it summarizes even the traditional approach. So this concept of probability value, please make sure that you understand it well. If you have not, and if you will not be able to capture or understand p-value in this lesson, please go and revisit it, revisit the same, especially if you must apply statistics in your research, which I believe you should. The probability approach now avoids all these mechanics and computation, and even trying to force these boundaries and looking at exactly whether it's on the right or on the acceptance region or on the rejection region. So what happens here is from the data, you will be able to compute the exact value of probability. Remember, the conventional ones are 5%, 10%, or 1%. Those are the statistically accepted levels of significance. The popular one is the one in red, 5%. So let's work with the one with 5% for now. If your 5% is your critical value, what it means is that the data will compute for you the actual probability based on the data, and then you'll compare that with only 5%, with the 5%. So please know that when you do, the reason why we give a smaller value for the alpha, which is the level of significance is because you are giving the rest 95% confidence. So you are assuming that your null hypothesis is right 95% of the time. You're only giving a 5% chance that it is not correct. That's why these alphas and these p-values, what you see here, are very small, because you don't want to form a very wrong assumption and null hypothesis, and then you fail to, and then you reject it. So you must give it a larger or a higher a higher confidence of not rejecting it. So this small is very small percentage, but I want you to understand how to interpret. So if you get from the data the probability of rejecting that null, which is now what is called alpha, the probability that you'll reject your hypothesis, which is what you call the maximum probability of rejecting it, is actually the p-value. So you will now look at it and compare it with 5%. And there are only two ways. There are only two conclusions. It's either the data will give you a p-value more than 5, or it will give you a p-value less than 5%, if you're using 5% as your cutoff. But it is upon you, the researcher, now to make sense of that value you've gotten from the data. I've just given an example right here, if you want to get it, the meaning of the p-value. So many of the tests you will see, you must always refer to the p-value. What does it tell you? What does it tell you? It tells you how rare your results are. Okay, how rare are those results? In other words, if I have a p-value of 0.025, that's like 2.5%. I hope you can see that. 0.025 is 2.5%. So vis-a-vis the 5%, you can see it's smaller. So it tells you that if you were to do this research 100 times, if 100 similar studies were done, then it's only in 2.5% of the cases that you'll get results that are such as yours. Okay, so the idea is that if your hypothesis is actually true, if I was to do 100 replication, then most of the time I should expect the same results. But the p-value now tells you that it's only 2.5% of those results that will agree with you, that will agree with the null hypothesis. And so if it is very small, 2.5%, then it means that you had a wrong hypothesis in the first place. So if you had a wrong hypothesis, it means that you reject what. So this is where when they say in statistics, times when I teach these statistics, I find students memorizing. They memorize this p-value and say, if the p-value is less than 5%, reject the null hypothesis. And it's true, but do you understand why you are rejecting it? This is the reason why you're saying you're rejecting a null when your p-value is small. It is because you're saying that if this is something that is repeated continuously, the results that you've seen, your null hypothesis will only be true 2.5% of the time, meaning ideally you are wrong from the onset. That's why we reject the null hypothesis whenever the p-value is very small. So ideally, you would want, if you are to agree with your hypothesis, then your p-value is expected to be more than 5. That is now the idea behind p-value. So I want us, as we go into the practicals, because everything we will be doing is referring to the p-value. And this is the critical slide number 8, which you must fall back to understand why we're rejecting the null hypothesis whenever the p-value is less than 0.5%. And as such, as you reject the null hypothesis, there will be some certain language you could use to just give it more meaning. So it is less than 5%, yes, but how close is it from 5? Or how close is it from 0? So for example, if the value is so small, to the extent that it's actually less than 1%, is less than 0.01, very small number. So it actually tells you that you have a very strong evidence or overwhelming evidence against the null hypothesis. So you have a strong, overwhelming evidence against the null hypothesis. It means that your data supports the alternative. Sometimes the p-value is some number in between, so there's strong evidence. If the p-value is slightly between 5 and 10, please know that 10% is also acceptable because of the 90% confidence interval. Because of this 90. So this says that it's weak evidence. But the moment the p-value exceeds 10%, you're saying that there's no evidence against the null. So the null will be, we will not reject the null. So I think this is some just additional way of giving more meaning to the p-value. So I'd like us, in summary, in statistical language, rarely do we say accept the null. So it's just a statistical language. We rarely accept the null because anything you accept means that you have complete evidence. But the evidence we are getting is just from the sample that you've picked. So we are never sure because it's from sample data. So the language that is appropriate is do not reject the null. So that is just a statistical language that is right out there. So before we get there, I spoke about parametric tests, non-parametric tests. I'll give more focus on parametrics today. So under parametric tests, these are tests that are widely applied, especially when your data is normally distributed with some mean and variance. When I say X, it means the data set is normally distributed with some mean and standard deviation or variance. But if your data is not normally distributed, you often go to the non-parametric equivalence. So there are tests in this family, and they are equivalent tests. So it all depends on the nature of the data you're working with. So the table 11, slide number 11, just gives you a brief picture of what we are saying. So when you're having a parametric test, it is consistent with data which is normally distributed. But on the other side, if your data is not normally distributed, you look for an equivalent test under the non-parametric approaches. If you have equal variation in the data set, then so we have the parametric methods application. So if your data set is on the higher scales, this was our lesson 1 when we began the semester. There are 4 levels of measurement of data. We have the lowest level being nominal including gender, region. Those are nominal variables. We have ordinal variables such as the Likert scales. Those ones you tell your respondents to rank data in a scale of 1 to 5 or 1 to 10. Those ones you're boxing them to a certain limit. So those are ordinal. So when your data is in this category, you don't apply parametric, you apply non-parametric. Otherwise, if it's continuous data, you use parametric approaches. And among the other things, so what I'm saying is for parametric tests, there are particular assumptions about the data. When the sample size is large, there is no outlier, you make assumptions about the data. You want to say, I want the data assumed is normal because it is more than 40 observations or something. So if you have very few observations, then you use the non-parametric approaches. When the sample size is small, when there's a lot of outliers, and then, so what are these methods though? Because I'm sure you're asking yourselves then, which methods are they? So table in slide 12 just gives you the same. And I've just given you a few, which are also available in statistical software. So depending on the research question, for example, so look at these 3 columns. The first column gives you the groups, or rather what you want to test. You have the parametric test, which is relevant for that test, and then you have the non-parametric equivalent. So for example, if you are just doing a 1 sample test, for e.g., you say the mean is 6.5 or 7.5 points. The mean mark, the mean score is 7.5. You want to test whether that is true. If your data is normally distributed, you do what is called a t-test. If your data that you're sampling is just from few students, 20, 30, then you don't do a t-test, you do what's called a Wilcoxon rank sign test. Wilcoxon rank, these two will serve the same purpose. Just want you to note that they are the same in terms of what they do. The only difference is that the test is applied to the data you are having. So always understand the data that you work with. If I'm comparing means between two independent groups, so for example, I want to say the mean performance in region 1 is higher than in region 2, and the data is normally distributed, I use what is called a two-sample t-test. Otherwise, you run what is called a Mann-Whitney test in the other side. So it's the same thing. So the others are provided as such. If I'm comparing, if you have two dependent samples, you can run what's called a pair sample test or a Wilcoxon rank sum test if you are in a non-parametric field. In the next chapter, we will do correlation. There's also correlation in the context of parametric, which is the Pearson correlation. Otherwise, we also have the Spearman's correlation. They are the same. The only thing is that the data will direct you to the right test to use. Finally, we have the analysis of variance. I know some of you have come across an ANOVA table. So if your data is normally distributed, you have more than two categories, like the one for groups of, like in the data set, if you are looking at mean scores per region, and these regions are 3. So you use an ANOVA table. You run what is called analysis of variance. If I only add maybe 20, 30 students, then I'll use the same test, but now I'll go to the Kruskal-Wallis test because the sample is not normally distributed. So I wanted you to I want to expose you to the various versions of the tests that are available. Okay, I want to pause for any questions before we now look at one or two cases. Let me hear what you have to say. I want to hear what you have to say for this lesson. We are usually very quiet. Let me get views. Oh, Othello, you are here. We were looking for you earlier, and welcome back.
You're looking for me earlier. I was on my way from Athi River. Now I've just arrived.
Oh, Karibu. Okay, proceed with your contribution.
Now, maybe you will help me to connect where we are today with these tests and at what point these tests come into play. Different tests that we have seen here, little bit complex. Thank you.
Thank you for your submission. Okay, all right. Let me get another contributor as well. Thank you, Othello, and then I'll make a comment.
Hello, Dr.
Great, thank you. Good to hear from you.
Good evening too.
Yes, good evening. Yeah, Jimmy, yes.
Okay, I think it will be, we will grasp the concepts that you've actually presented to us the best way possible if we use a practical example.
Correct. Okay,
yeah.
that's fine.
Be able to give us one, I think from there now we'll be able to
ask internalize.
More, exactly, as we ask more questions whereby we may need a lot of clarification.
Correct. Thank you. Yeah, thank you, Jamie. I think you've opened the way for us to move to this phase 2. However, it was also important for us to look at the reasoning behind what we intend to do today. It's good to understand what kind of what is the objective for hypothesis test? So for most of us who are in this, for most of us who are in the field or who are in the quantitative side of things, and because it's statistics, we deal with numbers. We're dealing with numbers. So when you're dealing with numbers, then it only makes sense if you apply some of these tests, some of these tools to give you more insights into the data. Frank, I've taken note of your comment. Yeah, so what I'm saying to answer now Othello, and then we go to the practical section, is for us to look at the data set that I've shared with you. So let me, I know Othello just walked in. If you are doing a study, let me start from there so that now we can contextualize everything. You have framed a research topic. This research topic is on, you want to understand student achievements, student performance. How can we be able to predict their average scores? So for example, the research question I have here, or the research topic, is something simple like, does performance in languages predict the average performance for a student? So that can be a question that you want to go and answer in the field. If a student performs well in languages, does it also follow that they will perform well on average? So that question, you could as well look from different perspectives. So you can do your, because it's a quantitative, that could be a quantitative study. You can go to the records from the registrar's office or from the principal's office. You can now record you can sample you get a good sample of student records. And if you see from my first column, I have data of mean scores for up to 200 students, as you can see right up to the end, 200 students. And then I have also recorded, this is now the mean scores out of 12. And then I've also recorded their average scores for the languages. If there are 3 languages or 2 languages, I do an average and I get the average scores. So if I want to do a study to understand whether performance in languages helps me to predict the overall performance of the student, you could do that. So the question you will ask, does language performance predict the average scores? So what that means is later, as you go to tests using hypothesis, you can now ask whether, is there a significant difference in the mean scores of the two? Is the average in total any different from the languages? So if I'm able to see whether the performance seems to be almost similar, then you could have a valid point. But it is good to just do the average. You can do the average and get that it's for the average is 7.5. For the languages, it's maybe 7.2, and you see it's different. But that is not statistics. It's not inference. That's not inferential statistics. Inferential statistics, we now say, even though I see that the average overall is higher than the language, is that gap significant or not? And that is what hypothesis is all about. Okay, Juliet.
Thank you, Daktari. Just a clarification. This column A, it is the average for the overall mean of the student, or the average for which subject?
For all the subjects done.
All the subjects. Then the languages is now the average for like the number of subjects the student is doing.
Like if it's English and Kiswahili,
okay.
Those are the 2 languages, you do an average So you get an average for English and Kiswahili, you record.
And this one,
Then
H size?
This is the also, this is now, I'm now saying, this is now the family size, how many they are at home, their siblings.
Okay.
So you want to see whether maybe there is a gender, of course, we know. This is the region where the school is based in. And then this is the years of, I call this one the years of education of the parent, the average years that they've spent in school.
Okay, sawa.
Yeah, whether the guardian is educated to what extent. So I'm trying to now, even though I'm saying I want to see whether language performance predicts scores on average, but you are also controlling for other things. You are taking into account other things as well.
Okay.
So that you have a bigger model that will encompass, that is wholesome.
Sawa,
Okay.
sawa. Thank you. Yeah,
Right.
thank you.
So Othello, as I conclude on your remark, I'm sure you've understood the context that we are approaching hypothesis testing from. That you have gone to the field, you've actually filtered the data, you can now make sense, arrange them, then you can ask questions. So for example, that is one, I gave you example of language, whether there is a difference in the language performance and the overall scores. Or when I began the lesson, I said, you want to also ask whether is the average scores different for students in different regions. So you can do a hypothesis test and say, is there differences in performance across the 3 regions? So you can, if you are not an inferential statistician, what you could simply do is average. You just filter, you compute the average for the north, you do the average for the west, and then you do the average for the south, and then you see the differences. That is what we call artificial visual, what the eyes can see. But in inferential statistics, we now unpack what the eye cannot see. That you could see those differences, but those differences are not significant. And this is what the language of hypothesis testing does. Thank you. Allow me then, we take you through
Dr. Now, the next question is under B. These numbers represent region, size, or this one?
Oh, this one?
Yeah.
This is the number of the family size, how many they are at home.
Oh, at home. Okay, that's
at
household.
home, yes.
Okay.
Yes, household size. HH size is the household size.
Okay.
Gender, region, years of education for the parents.
Okay, thank you.
So I've just sampled some variables which I believe can help to explain my main variable. In the language of, even before you get there, I'm sure you've done, I don't know whether you've done variables before. We have what is called dependent variable.
Yes.
And then the independent variables. In the context of what I've been talking to you from the beginning, which is my dependent variable? If I was to look at the question I've been framing from the beginning of this lesson, which is my dependent variable, which one is our independent variables? Because in research, you must distinguish these from the onset. The first one, dependent.
The main scores. The main scores.
The scores.
The
Scores,
scores
correct.
are
Languages.
And then the other ones?
Language.
Will be all,
Yeah.
in my case, I was focusing on language as my key independent variable. But I know that because I'm adding all the others, they help me to explain better the scores. Because it's not only the language that matters. All other things also come into place. And I think in research, you can now split these independent variables. Sometimes they call them intervening or mediating and the like, but they are all independent variables. For now, in statistics, let's call them independent variables. So all these other things help me to predict scores. So let's now go to Stata so that we can understand where we are. So for those of us who are punching numbers in Stata, we can then begin. First of all, I'll just highlight what Stata does for us. We may not complete the hypothesis test today because you must also have a feel of what Stata is all about. Just out of curiosity, how many of us have interacted with Stata before? Let me see by gestures on the chat. You can raise your hands a little bit. I see whether I have some disables in the among us. Okay. Othello, you've seen that before. Good. Tasleen, your microphone is
Daktari, I've only seen it in this class. When we did it before our breakout group.
Okay, I see you now. Okay, then
remember our breakout group. We mentioned the status before the breakout group when we did that last time.
I see you. Is any other person? Thank you. Any other person who've now opened and seen beyond what we outside of this lesson?
May I say something, Daktari?
Yes, Amisi.
Yeah, I think I still have a problem because I can't open Stata on a MacBook.
The MacBook. Now I need some. We might need to. For you now, we may not sort you today. I think that might need some technical expertise. So who is Amisi and who else?
Dr. Rim, me too.
Yes, just Cindy.
Me too.
Me too.
Dr.
Me too.
Let's you can list let me have your names on the WhatsApp group so that I can, in the course of my research, I see whether I can get something. But for today, we can follow up, then so that we don't stop for the rest of us. Let's do it on the WhatsApp group so that I can harvest those names from the others from the group. Okay, now let's open Stata by simply double clicking. Just like I told you, don't install anything, just double click on it to just use it straight on because it's already it's shareable. This is the version 11 how it is. It has a few windows, and I think in the last session I just described what these windows are. First of all, you have the menu that you can see up there. Just like any other software, it has all those drop-down menus which you can use. So in Stata, you can use these menus. So there are two ways of operating or working with Stata. It uses the menus, drop-down menus, as you can see, and including those other icons down there. Or you also use commands, which you now execute by typing them right in here. So I'm encouraging you, if you want to also learn about the menus, you can just look about the commands, just search for them. You can search for some of these menus. They are available, these commands, they are available online, including how to use each of them, but I'm going to just demonstrate a few of them. So number two is the windows that are available. We have what is called the results window. All these things which has these writings in here. So this is the results window where every result every test you do, every summary statistics you do, every regression model you run, they will be displayed in the results window. We have the variables window. This should be the first one I should have mentioned. This is where you will load all the variables. You will be seeing them in here, the variable name, the label, the format, and the rest. Then we have the command window, very important if you want to just run the commands. And then we have the review command window up there. So this one just copies all the commands you do. So before we proceed with anything, I showed you last week on if you want data, just go to sample data by going to file example data set. But today we are not going there. We want to load the data that you've prepared. Because ideally, I would expect that from your questionnaires, you come back and organize the data well. You put them in any format such as Excel, and then now you want to load into a Stata. Let me just take you through the shortcut procedure. There are a few things you need to do prior to working with Stata, and I think I've put them here in this slide number 14. Before you load the data, I would advise that you run the last three, you do the last three tasks, these three. The first one, you need to have a working directory, which means that you just need to create a folder in your favorite location in your computer and just give it a name. And then from there, you create what is called a log file. A log file is a file that will save every resource that you do. Anything you do will be saved automatically. I'll show you how that is done easily. And then the last step is to load the data. So before you load the data, just what you need to do, just do the first two. At times you can clear the memory if you've been running so many things previously by just typing the command clear all. Because this is the first time you're using it, there's no need for that one. But in case you want to clear the memory, you just type the command clear all, and then it will just clear the entire memory, and then it will be fresh. So you just type the command clear all, and with space in between, you enter, and then it will just clear the entire memory like that. But that is not important for the beginning session. So first things first, let's create a directory. If the easiest way, because we are doing it first time, I want you to create a folder somewhere in your computer. Perhaps let me create mine let me see whether I can do it in the desktop. You can just create an empty folder here. Let me create mine and a new folder in here. I'm going to call it ELP614X. I've just called that one ELP614. Good. So that will be the directory. So what you will now do is link Stata to that folder so that everything you do will be saved automatically in the folder. If possible, you can also save, if you can save that data set there, I can copy it there. I can copy the data so that I know that everything I'm working with is in that folder. So I'm just copying the data set into that folder as well.
Excuse me, Daktari.
Yes, please.
Please, could you repeat the creation of that folder?
Okay. The creation of the folder. It's a normal way you create a folder anyway. So if I'm on the desktop, I simply right click, right? If I right click, I go to new, and then a new folder, just the way you create folders. Hope that is clear. Can I get an okay?
I'm still working on it.
Yes. Okay.
I've never done one before. I'm
Doc.
just used to doing things directly. I've not really done folders, so I'm
Always
still struggling there.
It's good to do folders because it helps you to organize the material properly.
We are
Otherwise,
learning step by step.
Yes, good. I'm just encouraging you. Otherwise, the desktop will be so full. Yes, excused.
I've created the folder, but how do I open this starter? Is it starter? That's the way you are.
Oh, the folder. I hope you got the folder that I shared. This S11, which I shared last week, part 1.
Yes, I have,
you have
the
it here.
S1. Yeah.
You double click the last one down there. Just open it by double clicking.
I double click the starter SE.
Yes, the application.
Okay. Double click.
It will just open like this. Yeah, hopefully it will work.
Oh, yes, I've seen it.
Nice.
Oh, thank you.
So let's link.
Has refused.
Which one has refused?
Folder.
Okay.
I'm really struggling here.
Okay, what you do then, you can save it in the desktop without creating the folder.
What about, okay.
Yeah, because the thing is, you just want somewhere where you save data, nothing else. Yeah, you can still work without the folders, in other words.
Okay.
So you can just link it to the desktop.
Excuse me, Daktari.
Yes, please.
Kindly repeat on how to link the folder to the data.
How to link?
Yeah.
Oh, I have not done that. I wanted to now do it now.
Okay.
Okay, let's all have the data opened, and you go to File. First, go to File. Then Change Working Directory. Click on Change Working Directory. Have you clicked on that?
Yes.
And you click on it, it will now take you to that folder you want. For those of us who do not create a folder, you can pick your desktop if you want. But if you have a folder to work with, mine was ELP 615, which is this. You can double click it or just highlight it and then you click OK.
Done.
Done. I think that should be it. You should never, if you have red marks in the results window, then there's a problem. But it should be as clear as that. So I hope you're noticing something. Every time you do something, there is a command which is written automatically.
Yeah.
It's called CD, which is change directory. And whatever is quotation marks is the link where that folder is. And then number 2, the review will capture that command and record it automatically. So step 1, preliminary done. Step 2, let's create a log file. The log file is the way we will save our results. So I'll still go to File. Okay, from the file, you go to Log, Begin. I want to click as the last person, assuming that everyone has done that. File, go to Log, then Begin. When you click on it, you locate the same folder again. Make sure you go to the same folder where you had created it. Mine was called ELP 614. I double click on it. So I'm inside the folder. If you had not created one, you should be on the desktop, or yours should be on the desktop. Are we done? Don't click save yet. I'm waiting. Just keep waiting for me. Once you are in the folder, you can give it a name. Because if you notice, it was highlighted before. Just give it a familiar name. Initially, it's called untitled, but let's just give a name of results, for example. Don't click save yet. Wait for me again. We are just going step by step. We are changing the name to something familiar. You can call it anything, by the way. You don't have to call it results. But then this format is the one you need to change. Change this format to what is called a log file by simply clicking on this last penny or going to the arrow. Whichever way, click on this arrow there and pick the second one. This log file is okay because it's easily openable with a normal notepad. You can open it with a notepad. The other one, you will not directly open it unless your computer has the format which can open as an SMSCL format. You're picking the second one for ease access of that. Once you've done that, click save now. Once you've done that, save. And I want to hear that we have clicked, and so that I do it as the last person.
Yeah.
Yes.
Good. I click save. Now the other command has come up there. Now the last step is to load the data. So let me just, let's do copy and paste, which is what everyone likes.
Daktari, what do you like? Tell us what you like also.
I prefer the copy and paste. I also like it because it's faster.
Okay.
It's efficient, yeah, it's faster. But otherwise, the other way is to load it different by uploading. If I must upload, Stata 11 does not accept Excel. What the other way is to just go to file, import. Please don't go this way. You go to file and then you import the data from a spreadsheet. And then you choose the file itself. But what I know, Stata 12 and beyond will accept Excel. But let me not go to that process. Yeah, because it will require that we save this differently, which I didn't want. So what let's just copy the data by highlighting everything. Just highlight up to the last. Don't highlight everything, the entire workbook or the entire sheet, but just highlight the sections I've given up to 5.3 and copy. Click copy. So we have copied the data. Please don't paste until I ask you to do so, because there's something else before you paste you must do. So I've already copied. I go to my Excel, my Stata, sorry. From the Stata, where do you paste? Please don't paste it here. You should look for the spreadsheet for the same. So go to the editor here. If you see a spreadsheet like a icon here with a pen, that is an editor. Next to it is called a data browser. So don't go to the browser, go to the editor. They serve the same purpose, but there's a difference. Click on the editor, the window will pop out. Are we done?
Daktari, for that one to come, you go where?
You just click on the icon itself, the editor, data editor. Click it once, it will pop out.
But I'm not seeing it.
Really? It's not there?
Can you show me there? Where?
When it pops up, it is empty. Oma, we do what?
Yeah, it is empty. Yeah, it must be empty. Because it's like a spreadsheet. So when I click it, it comes out like this. So from here, just paste. Let's paste. But then there's a choice to be made there. I would like to ask, which one do we go with? Is it the first or the second?
The second.
Yes, go with the second one, because the second one has variable names on the first row. Please don't pick the first, pick the second one. If you pick the first one, these names will not show. It will write as variable 1, variable 2, variable 3, and the rest. And that will be confusing. So this is what you can see in the data. So this is the data loaded. Before you close it, I hope you notice that Stata identifies the variables differently. There are some labeled in red, others in normal black. This is now what we call the levels of variables with various levels. The ones in black, what can you see? They are actually continuous data sets. Anything that is not numbers, Stata will put them in red mark. And these variables are the two, gender and region. They are in red color. So these in red color are called string variables, string. So those are string variables. Yeah, otherwise, the others is just the normal observations that we know. Now we can just a minute.
It's like mine has something different. I don't know where it has come from.
What do you have?
There's a type. There's after the year of the education of the parents. There's type. I don't know where it has come from.
Okay, I think that is the data that we deleted. It's okay. I think if you joined after the class has begun, we deleted that variable.
Oh, okay.
Yeah, it's okay, but let's just have it there.
Okay.
So close this one. You can always close it. There's no harm because it's not gonna get lost. It will still be there. You can record it anytime.
Close without saving, or you just leave it there like that?
You don't have to save because it's never erased.
Okay.
If you want to save it, you just go to we will save it at the end. Let's not save it now. Now, for Stata, there's a difference between the editor and the browser. If you look at the browser, if you click on the browser, it has the same information. Browser means it is not for editing. It's just view only. But editor, you can remove a variable, you can change a number, you can change a number to whichever. I can change 6 to anything. Before you as you change that number, you click outside, it will ask you whether you want to really change. Then you can click yes or no. But for now, I'm not going to change anything. I'm going to just leave at no. So editor, you can edit anything here, but the browser, you can't. Done. So these are the 3 things you needed to do before you do anything with Stata. I hope you've seen that the variables window is now populated with things. It has a variable name, the labels that we've given, the type, and the rest. So that's what it. So we are now ready to do analysis. So step 1 passed. Now, next thing you can do is to do very basic statistics. What we've been doing in chapter 3, 4 about summary statistics, they are all here. So I will encourage you to just play around with the icons now. If you want to do a graph, they are all here. For example, you can do, let's do maybe a 2-way graph. Just pick one of these. Let's do a scatter plot by clicking the one for 2-way. Yeah, 2-way graph means you have you need to have an up and y and x-axis because it's 2-way. So once you are here, you have to create the graph. From this one, you click create. So the features.
Like I'm lost.
Yes. Where are you?
Where do you get the 2-way graphs?
Graphs. When you go to graphs, the first one.
Graphs.
Are you there? Yes.
Yeah.
When you click graphs, the first thing you see is 2-way graph.
Graphics of graphs.
Graphics, sorry, graphics. Graphics, 2-way.
Graphics or graphics.
Yes.
Okay.
Then you create it. You can create by clicking on create, and then now you can choose scatter plot, the one that we are looking at. All you now need to do is put the variable, the one on the y-axis and the one on the x-axis. Put your dependent variable here. The dependent variable is score. You use the arrow here to select score. The other variable is the languages. And then you see what comes out. So once you do there, you can either do
we accept.
Yes. There's a difference between accept and submit, but they all serve the same purpose. If you click accept, this window gets out.
Which window?
The one for the graphics itself.
Okay.
Let me show you. If I click accept, you see that window has disappeared. The same will also happen here. And then your graph will appear.
Okay. But if you click submit?
If you click submit, it means that you are telling Stata you still want to do another upload, or you adjust. It will not, those other windows will not pop out, or rather they will not disappear. Yeah. But for sure, but really there's no really difference.
Okay.
It depends on whether you want to still edit. So let me repeat, graphics, 2-way.
Excuse me, Daktari.
Yes, please.
Mine is not showing. When I click the graphics, it's not bringing the drop down.
Ah, okay. I think this version of set at times does that with certain computers. I've had such before, but it's only the graphics features, but the other things do work. I think I acknowledge that. Perhaps it could be the settings that is not compatible with your the graphics utilities, or is not compatible with your computer. I want to believe so. It's not the first time I've seen that, but but you can still follow later on. I don't know that you could preload, perhaps, yeah. So click on that one. You can, because it was plot 1, you can say edit. Because I'm just going to the same one where we were before.
Are we continue?
No, not necessarily. I just wanted to show us the submit option.
Oh.
Yeah, if you click submit, the graph will draw. Same graph will draw, but these other things will still remain.
Yeah.
So that's the only difference, but there's really nothing fancy about it. So I want to ask you to look at the other graphics. You can even
read this graph because I'm just seeing dots. Oh my God.
That's what happens when it comes. Scatter plots are like that. You know, when you're saying scatter plot, there will be 200 dots. You know why? Because there are 3 because there are 200 observations. You are simply plotting this one and this one. That is 1 point. Another point is this one and this one. So there will be 200 of them. That's why it's so much populated there. I want to assure you that that one is difficult to interpret. The purpose for a scatter plot, it is to show you the nature of relationship. A typical scatter plot which can give you some interpretation, something you can interpret, will appear like this. So this is my independent variable is languages, and the other one is scores. So I would expect perhaps something like that. You know, if you have a pattern like that, it can now tell you a story that it seems that the numbers are rising, lower values for language performance match lower values of scores. High values on the other side are matching with high values on the other side. So you can actually form a relationship here. So you can consider there is a positive correlation. We will deal with this next topic. So the purpose for us to do, yes, please.
After choosing the scatter and then you put the variables score and language, what do you do? Do you expect Z or you submit?
Oh, who can say that? Who can ask? Who can respond to that?
Submit. Either way.
Okay, whichever. Thank you. Choose whichever.
Then after that,
you click OK. Yeah, then your graph will appear. Okay, so I was saying that your graph should have the graph can give you a picture about the correlation, the nature of relationship. In our case, it is not very clear because I can't see a pattern. See, if you look at, sorry, I'm opening a different one.
My graph has not appeared.
It could be the same issue with the one that
variable score not okay.
A score is not there.
Yes, variable score not found.
And you have this on the variables. You should see score.
Which one?
On your variable list, it should be there.
How to copy part your score when you are copying from?
Yeah.
It's the same problem, but I realized I had not copied some values.
Okay, so I go back and
copy.
Yeah.
So for you, just before you copy
again.
Before you copy, you must clear this one. You type clear all.
Okay.
So that you start afresh. Or alternatively, just what you can do, before you get, because if you clear all, it means you erase everything, including what you've done here. But it's okay, just clear all and then paste, copy and paste, copy and paste afresh. We are learning. We are just learning things.
Okay.
And just okay. So clear all and then paste afresh.
And so, Doctor, when you have typed clear all, I expect everything that is there to go away, or it will still remain there.
The variables will go out. All the variables will disappear. But your
variables.
Yeah, only because the
and
data
what
is.
About the command up there?
Commands will remain.
Because I think I also made a mistake. I didn't highlight all the whole graph. I just took like the first 18, and so it means I'll have to do it afresh.
Yeah, just do it afresh. It's as simple as that.
Okay. After writing the command, where do you click so that it clears?
Just hit enter on your keyboard.
Okay.
Fine. I'd like you to. I'd like to ask you to go to. Let's do summary statistics. The mean, mode, mean, median, the things we've been doing before. Anything numbers, you go to statistics. Click on statistics, and the first line there is summaries, tables, and tests. All the numbers are there. Summaries, tables, and tests.
Tables. Why it's so wide? The more you go, the deeper you go, the more they appear.
Which one? So
so it's on the first.
The first site item on summaries, tables, and tests, and then you go ahead to the summary.
After writing the clear all after enter, mine is saying that there's an error while loading clear.
Did you write in capital letters?
Yes.
Use small letters.
Okay.
Yes. Yeah. Stata uses small letters. Yes. Fine. It's okay. These are some of the skills you must go out there having known, because it's one thing to collect the data, but it's another thing now to process it. Yes, if you are with me, you can go follow the path I've indicated there.
Up to mean.
Up to, no. The first one is summary statistics. Is it refusing?
Yes, it is just writing clear and it is being added there.
Now, quick one. What is in your, if you click your data editor, what do you see? Here, this editor here. Do you see anything?
Data
is your editor?
Edit.
Do you have data there or it's empty?
Data edit. I cannot see it. Where are you clicking again?
Right here.
Okay, yes, it is there. There's nothing.
There's nothing.
Then
what
black.
you do then? Then load the data then. Just copy, paste here. Paste. If there's nothing, just paste it. It will show. It will copy.
I go and copy again and paste it here. Okay.
Correct. Okay. Finally, as she's catching up, what do you notice? What do you get from what I've asked you to do? Summary statistics and summary statistics there. Have you clicked on that? I want someone to tell me what they're saying before I click on mine.
Yes. Means, proportions, ratios, totals.
Yeah, so pick the first one, the summary, which has everything, most of the things.
Okay.
Click on that one, and then you can now select the variables you want. Let's do, when I click summary, can I proceed by clicking it?
Yeah.
Yes, now here on the first row right here, you select the variables of interest. By going to the arrow right here, If I click on it, the variables appear. So you can now pick them one by one. But you should know which variables are you looking for. Pick the variables with continuous data, with the one with numbers, because you're looking for summary statistics. You cannot get a summary statistics for gender. There's no average for gender or region. So the ones that you can get is score. You click it once, you go to household size, you pick another one as well. You go to years of education, and you go to language. Those are the variables which have numbers. Those are only 4. You realize that that thing is not going. It is still asking you to select more, but you don't have to. But once you selected the 4 of interest, just click anywhere outside of this drop-down menu, right? Like outside here. Click it once so that this thing just disappears. Or you go back to the arrow. It will take it back. And then now we're good. So before you click OK, this, I want to demonstrate the submit, because I don't want this window to go pop out. We can still do summary statistics beyond the normal. So if I want just summary statistics for this one, just click submit. When you click submit, you see this window is not moving anywhere because I want to come back to it. So this now gives you the things we've been computing. The number of observations are 200 in each case. The average or the mean is this one. And then this is standard deviation. We have the minimum and the max for each variable. I think this table is understood. No one has problems with it. Good. Question. What is the average mean score?
Average mean score of what?
For the performance. We are dealing with average score.
8.0225.
So you can say that on the average, the average performance for the students in the county is 8.02. With a standard deviation of
1.4.
1.46. Now let's move to the performance in the languages. So the average performance is around 7.28 with a deviation of
2.01.
Yes. Now because we've done chapter 3 and 4 with you, I want now we make sense out of that. It's one thing to just get and get numbers like this, but then when you are writing those sentences, what do you say? You can easily just say what we've said, that the average is 8 for the overall scores, which is slightly higher than that of the languages by about 0.8. But that is not it is good statement, but it's not useful. Statistically speaking, what can happen here is when you say on average, the average score is higher than that of languages, it might be useful to look at the deviations. So it means that much as this is higher, there's a small variation among students' average scores. So comparing the two scores, the English and the languages and the scores, the average, even though the average score is higher, there is less variation among students compared to the languages, which shows there's a higher variability in performance in the languages, because the standard deviation here is higher than the other one. So this standard deviation is useful to now compare variation within the sample. especially for things that are related to each other. So especially scores, they're all scores. This is a score for the overall, this is a score for languages. One can actually compare. Much as the students have performed well, even in the English language, because it's more than half because it's maximum is 12, 7 is above average, but there's a slight variation. Means that there are some students who are doing poorly, whereas others are performing well. Good. Now let's go back to that. Yes, please.
Yeah. So, Dr. What is your representative figure that you are going to look at to present in your findings? Because now
in your
with this
findings,
variation, yeah, what is the representative figure? You get to this point.
When you have a table like this, there's no harm presenting the table, yes. But the storyline is you can pinpoint a certain a certain interpretation, like what I've told you. If that is a finding that you see it is useful to mention, then you can pick and compare variation between students. So the mean is a good indicator to mention. If I was to go now to specific, the mean and the standard deviations are very useful indicators for me to mention. If you were to ask me which is the key output or outcome you want to give out to audiences, I'll focus on those. So you can actually get this data, this table. You can actually edit it. If you don't want to produce it the way it is, you can as well do you can do a summary statistics for only the two things, mean and standard deviation. There's nothing wrong with it. So in my view, whatever you present as a result, just make sure that you say something about it. What I've seen in most studies, people mention a lot about average. They tell you the average number of households or the siblings are only 6. On average, the years of education for their parents is 10, which is not as bad to mention in a finding, but to me it might not really add value to interpret the standard deviation for that. Okay, it's okay. So I think generally this is what.
Okay.
Now, if you want more, if you want to look at more things in your analysis, let's go back to this table here. We've done the same variables, but I'd like you to repeat and want to look at the averages for the different for the gender, across gender. So you go to the by option. The same things, click on the by, and then you repeat the process by gender. I click on gender, and then I click outside or click on this arrow. So what you will do is that you are now doing summary statistics separately for the male and the female students. Then you can now see differences in those averages. Once you've done that, I don't want to come back to this one. Let's just click OK. Let's click OK and finish there. So once you click OK, you have summary statistics for the male down here and the one for the females. So if you are interested in artificial or feature just comparison by observation, you can look at the average score for the male.
Lord, I got lost here.
Come again? All right. Okay. Fine. Let's
somebody wants to know how we got this table spread very fast like
that. And yet in the class we did it manually. So can you repeat your question again? Was asking?
That was Taslin.
Taslin, eh? Yes, it's okay. I think Taslin, I've understood what she meant. Okay. But I
Well,
hope you
how are
follow
we getting this nib after I was left behind looking for the
Oh,
graphs?
okay. Okay.
You are
Go
going to
to
statistics, yes.
summary.
Yes.
Summary tables. Go to the first one, summary statistics. And I
No,
click
no,
on
no,
it.
no, no. I have
Summary,
gotten lost, but I've now found one. I'm
summary
Are we okay?
statistics. Summary
Yeah, just
statistics.
the first line all through.
Yes.
Summary up to the one for summary statistics. Right here, click on that one.
Okay.
And then you pick your variables.
Pick the variables.
Okay. The variables are
What are we
here.
picking? What are the variables here?
I thought we were doing that before. Where were you?
The time my graph got lost.
Surely we have to move on. we move to the next concept. You pick it later.
Okay.
Yeah,
I'll follow up with the YouTube.
you can
Yeah.
follow it later. Thank you. So that you can use the time to get. You can also learn the other things as well. Thank you.
Okay. Okay.
Now let's if you are to look at the.
I have a question, Daktari.
Please ask.
Yes. I have seen colleagues asking for Chris. Sorry for joining late. Honestly, I logged in while in another serious case that I was handling. So I was actually asking, where are we? I've seen it as answered me, starter. But then the question, Daktari, are you able to do some remedios for me? Because then it seems like I am just zero.
We might need not just for you, then we'll have to redo for everything at some other time then.
There's a YouTube recording.
Yeah.
Honestly,
Oh,
even
sure.
if I listen to the YouTube, I may not get it.
I think you will. That's the right answer. After the link, pick. If there's a question, we can ask another day. I think that is only fair. Cindio?
Yes. Yes, for now, Daktari.
For now, yes. You have to be
Yes.
fine. You have to be fine. With the recording, I'm sure there'll be nothing to worry. Now we've done summary statistics for the 4 variables. How about the ones for region and gender? So for those ones, because they are not continuous variables, you just do a table. You do a tabulation. So let me just show you the other way of doing it.
In our ladies group.
Okay. So I want to take you to the command option. For variables which are not continuous, you can do a tabulation. So what I'm saying is that you can, once you've mastered data, instead of going through the statistics and the rest, just go to the command itself, tabulate. Tabulate will give you tables. You're getting a tabulation for variables which are not continuous, like gender and region. So when you type tabulate, so that's a command called tabulation. It will give you a table of percentages. So from here, instead of typing gender, just double click on the variable. After you've typed the command, double click the variable gender, it will just pop out straight on. You come to the region, double click, it will be like that. So that you avoid spelling mistakes and the rest, and capital letters. Once you've done that, it end. But I want you not to go that way. Just pick one at a time. When you do like this, you get other complicated things which you don't want to go to. Let's pick gender first. Tabulate gender, and you hit enter. You get your proportions. So it tells you that 56 in the sample, 56% are females, 43 are males, 43%. And the rest. So that is useful information for you. Good. Let me, if you were to redo a command, that you had done before.
Hello.
For example, if I am to...
Oh, fine, fine. Did you confirm?
Helen?
Helen, can you mute, please?
Yes, fine. I've done that. Okay, nice. Instead, this review command window is very important. In case you want to rerun a certain result, maybe you had made a mistake and the rest, you can actually recall a command and then do it again. Let's do a mistake. Let's do a command which is not there in Stata. For example, if you want to type summer without a Y, or even let's put summary. I want to show you something. Let's do summary of scores and languages. I'm double clicking. If you want to pick a variable, just double click on it, it will just come there. If I write the command summary and then score and languages and type and hit enter, what you notice is that you have some red marks, unrecognized command summary. So whenever you see red marks on this side, on the results window, the same red mark will be appearing there. It shows that that's an error in command. There's no command such as that. So you'll now be forced to rectify it. So if I want to now do the right thing, and I think you want to recall a command up here, you can go to any. Let's, for example, the one for summarize. I'm picking the one for number 6. I don't know what number it is for your case. You just tap it once. When you click it once, the command will appear here. That's why it's called a command review. So I click that one, it will be repeated here. And then you can now enter if you want to rerun that command. So you can do that by recalling certain things if you want to repeat. That's a beauty with Stata. If in case you get stuck with the use of a command, there's always an help menu, help feature. As long as you know the command name. For instance, if I know there's a command called tabulate, but I don't know how to use it, you just need to use the command help. Ask Stata to help me on tabulate. You ask it, give me ways of using this command called tabulate. Once you have gotten it right, make sure that it's a valid command. You hit enter. So the help menu feature will appear, sorry, it will be right here. Yeah, it will tell you that it helps you for when you're doing tabulation of numbers, two-way, and the rest. This one doesn't even give you more. I wanted to pick another one which has more explanation. It's okay. We'll get another one at some point. But the command there, help, is useful. So before we wrap up, I want to ask you to play around with these things in Stata. Do histograms, do pie charts, and the rest. You can do pie charts, you can do anything statistics, just play around. There's nothing wrong with getting errors. That's how you learn. That's how you learn. Okay, having said this, so that I don't lose the topic for today, perhaps you can just demonstrate these ideas of hypothesis testing. And this is what I have provided in the extra attachment to the notes. This is the parametric test available in Stata, and I've given you, I think, up to 5 tests. There are 5 of them, up to analysis of variance, ANOVA. And I've given a small narrative to what each of them is doing. So if you have you want to test certain very basic claims, for example, suppose in a report issued in one of the schools when you're in a meeting and someone just reads the reports from the Ministry of Education that the average mean scores in the county is 7.7 points. But then at the back of your mind, you have some picture about the performance and you believe that this number, much as it is given as a statistic, it may have come because of just a simple averaging of a few schools or something like that. But you can now use this as an null hypothesis to test whether indeed the mean score is 7.7 or it is different from that. So having said that, you want to test the null hypothesis. Let me just write it in here. So the null hypothesis is that the mean is 7.7 points against the alternative. The mean mark is not equal to 7.7. So you can now go and test this by considering sample data from your county and see whether that can reflect maybe the claim made. So you see, so you can use sample evidence to just test whether that is valid. So you run a t-test using the information and from the data given. So what you need to do in Stata, all the tests that I've showed in the slides are available under statistics. Let's all go there. When you go to statistics, summary tables and tests, from the summary tables and tests, go to classic test of hypothesis. So the classic tests of hypothesis are the ones that are in the parametric sphere. Otherwise, you have the non-parametric tests just below that. Let's just see the names only. When you see the non-parametric tests, you will see some names that I've already given you in the slides. You've seen me mention Chris Kowallis, Wilcoxon, Spearman, and the rest. Just to mention a few, but you don't have to use everything though. So let's go to the classic test of hypothesis. These are the classic are the ones for the parametric. The test that is being tested here is the first one. One sample mean comparison test. It's just one test, one sample. You want to test whether the mean is 7.7 or different from 7.7. I click on that one. Then this window for the t-test opens up. So you are running a t-test, mean comparison test. So you are comparing a variable to an hypothesized mean value. And the variable of interest is a score. Click on the score. You want to test whether the score value is equal to the value hypothesized as 7.7. So you put in there 7.7, and this other one, the score value. This is the lesson we did last week, 95% confidence interval. We did confidence interval construction, and we mentioned that we have 97 and the rest. If you look at this arrow here, you have up to other confidence interval, 99, 95, and 90. Those are the conventional ones, but default always is 95. Good. Having said that, you can click sub. Okay, let's use OK because you don't want to repeat this test.
Mine doesn't have the hypothesized mean, or did you just put it yourself?
You put 7.7. This one you put yourself. Your hypothesized value of 7.7.
Yeah.
You see, this is this came from maybe a number that is maybe suggested or from theory and the like. For example, if I want to assume that, for example, in East Africa, assuming we have the same grading system, if previous studies or previous results over the years have shown that the average performance in high schools in East Africa average 7.7%. So you would want to take that one as an hypothesis. You want to say now this year, I want to test whether the scores this year, is it different from what is documented? So this is just an educated guess. Once you've done that, hit enter, or sorry, click OK. And this is what matters for hypothesis testing. Whatever I'm highlighting, this is key. If you know how to read these numbers here, and don't be scared with so many numbers in here. I'll only ask you to focus on the relevant one. Every information is useful there, but there's only one important variable, or rather result. So let's just look at it. First of all, we have the command t-test score double equal sign 7.7. That is the command. If you're doubting, it's written here. T-test score double equal sign 7.7. Then the test gives you the things we've seen before. We saw the number of observation. You already saw a mean. You have a standard error associated with it. We have a standard deviation, which you already have mentioned. This is what we did last week. Confidence interval. When you're constructing the confidence interval, it tells you the mean of 8.02 lies between the lower value 7.18 and 8.22. This is what we did last week. So that's why we thought we would do it manually this last time, but now we can actually see where it comes from. So the only thing what we're doing here is, because we have a large number of observations, it becomes tricky to even sometimes compute some of them manually. But with the standard error or standard deviation, you can calculate this one based on last week's discussion, but let's not go there. What matters is your understanding of the null hypothesis. The null says the mean is equal to 7.7. And then whatever you have down here are the three versions of the alternative. Do you want to test against a mean less than that one? Or you want to test this against the mean of greater than 7.7? So the two are the one-tail test. The left-sided and the right-sided. But the one at the center here is the one that is saying it is not equal to. It now tells you is the mean. You are now saying the mean is 7.7 against the mean is not equal to 7.7. So these are two-tail tests. So I just wanted you to know how to interpret theta output. It will always give you in this format. So, but what you will be doing is you will just pick and interpret one. For now, we interpret this one. And this PR is the p-value, which we mentioned earlier, the p-value. And to me, I only need two things from all this. What are those two things? I need the hypothesis, which is I need to understand that the mean is the same, or sorry, the mean is equal to 7.7 against the mean is not equal to 7.7. And then the second thing is that what is the p-value? Is it less than 5% or greater than 5%? What is this percentage p-value here? What percent is that one? Yes. What is the percent? What is the p-value there? I'm asking something that you can see. The actual number in percentage.
2.3%.
2.3%?
0.23%.
It's 0.23?
0.
Just multiply.
Percent.
Yes. Yeah, multiply by 100, you get 0.23. Is it less than 5%?
Yes.
Yes.
If it's less than 5%, what do we do with the null hypothesis?
We uphold.
Uphold?
Nini unacheka?
Kama basi Otelo, you need to
Mambo
ask us.
imecheka.
Otelo is smiling. We do what? Reject. Please go to the slide number 8, if I remember. If you are stuck, refer to slide number 8. This is your rule number 1, rule number 2, rule number 3. If you don't understand rule number 3, go back to slide number 8. Always, the key thing is that if the p-value is very small, reject the null hypothesis. So in this case, we are rejecting because the p-value is smaller than the 5%. So what is the conclusion? The conclusion is that the mean score is significantly different from 7.7. Full stop. This is how you now conclude. If you did not do inferential statistics and you are reporting results, you will only say the average is 8.02. And it is different from the 7.7, which is the hypothesized value. So you can only say it's different, but you cannot say statistically significant, or rather it is significantly different. So that's the language that we bring on board. Yes, I'm going to demonstrate the last one. I'm going to demonstrate the last one, and then we take up the discussion again the next time.
Okay, Prof. Dr. Before you go to you demonstrate the last one, is it random that we got this 7.7? Or is it random? Coming from somewhere? This 7.7, is it just randomly suggested?
Okay.
Or we got
is it randomly suggested or not?
Okay, thank you.
That's a good question. I don't know if I need some help. Yes. Are you responding?
Yeah.
Try, Josephine. Thank you.
Okay, you get it from researches that have given the value, the figure. Okay. So I was just asking if I reduce the 7.7, the hypothesis.
Oh,
what if
you're getting lost a little bit.
What if I reduce the 7.7?
Oh, to another number.
Yeah.
Okay, no problem. You can still test it. That is why hypothesis testing is powerful. It enables you to, it is flexible to accommodate whatever. And then I will do that, and then we'll demonstrate, we'll show it shortly. But I wanted to respond to what you said. This 7.7 number here, I agree with Josephine, it has to come from somewhere. This is the null hypothesis. The null hypothesis is not a random number. It has to be informed by either some theory or some known conclusion about a story. It has to come from some source. In this example, I've given it as a number for demonstration purposes. But when you are doing it now in actual fact, in real time, or in actual research, then you must justify that why did you pick 7 and not 3? I gave an example. I said, for example, this 7.7 could be the trend for the last 10 years in Kenya. So that is documented. You see the way they even read news and they tell you, oh, on average, our performance have been 5.5 every year for the last 5. So it becomes a global picture, a global scenario, which seems to be a claim about the population. But what we're doing here is we want to validate that that claim is true or not based on sample evidence. And that's what you've done here. You've collected a sample of 22 or 200 observation, and then you run a test to see whether you want to validate that argument that is believed out there. Full stop. Having said that, for another test, for the sake of Josephine, you can actually reduce this. So instead of us going to the same table, summary, classic test of hypothesis, just click on this t-test here. Just click it once. It will come here, and then you change the number to whichever. Then you just click enter. So it's the power of the review command. You can recall a command and edit before you run it. You see, when I run with 7, the p-value is even 0. It means there is even overwhelming evidence because the p-value is actually 0. So which means that you are rejecting the null hypothesis. There's overwhelming evidence to reject it. So which means that the average in the population is different from the hypothesized value.
Did we click on statistics to get to the t-test, or we just look at the t-test that is shown there? Yeah, that's what I wanted to see.
You must check it. You know, there are 2 ways. You go to statistics, summary, tables, and then you go to classical tests. And then you pick the first one there. That's where you get the t-test.
Thank you.
Okay. So on that note, before I leave there, then let's all go there. And I want you to pick the 4th one. 2 group. 2 group mean comparison test. So you want to compare now the scores or the mean scores for 2 groups. Please know that it's only 2 groups, not 3. Click on that one, and then you select the 2 variables as the scores, and the other one is gender. You want to compare whether there's a difference in performance between the boys and the girls. I'm clicking on that one. This is the last test we are doing, and then I give you one, you do it in the course of, you can play around with the other tests later. Having reached here, 2 group mean comparison test, the variable of interest is the scores, of course. The other one is the group name. You are comparing by gender. So this is the grouping variable. You're the one that you're separating the scores with. And because gender is the only variable which has 2 categories, I've picked on that one. Before you click enter, it might be useful to have some information about variances in this data set. I remember we had done it before. We saw that the variance or the standard deviation actually for the scores was 1.4. And the other one for the, I think you need to look at whether there's a difference in the variances between genders. So it's always safer to look for, to highlight that one for unequal variances, because you want to assume that there's equal variation across the ladies and equal variation across the men. So it might be useful to just use the unequal variances to just take note of the fact that you are not assuming away constant variance. Click OK once you're done. So the null hypothesis is very clear here. Remember, you are comparing performance by gender. The t-test, you want to compare the scores between the 2 categories, assuming that we have an equal variation. Having said that, you can look at the mean, the null hypothesis. The difference is equal to 0. It means that there's no difference in the performance of males and females. So that is a null hypothesis. The males have performed equally as the females. Good. So as before, let's interpret the center, the one at the center here, the p-value. I told you just look at 2 things, understand the null hypothesis and look at the p-value. Noting that it was at 5%. So what do we conclude? What is the p-value? Probability is, what percentage is that?
29%.
29%.
Okay, which is now referred to slide number 8. Being 29%, what does that suggest about the null hypothesis?
About
Do
5%.
we reject or not reject?
Not reject.
We
Not reject.
Exactly. So we fail to reject. So if we fail to reject, the p-value is higher than 5%. It's actually 29%. So you fail to reject. So when you fail to reject the null hypothesis, what are we then concluding? We conclude that the performance of both the male and the female students is the same. So we are failing to reject the null. So you must always, yes.
Before we finish our conclusion there, we do not even have a single margin of error in this to accept that the performance, there is no difference, not even 0.0000 something.
In all cases. Yeah, remember, this is, here, the data has been split into the female and the males. And even the variances for each of them has been defined. So they even are very close, actually. So the idea is that you are trying to focus on what? The null. The null says, well, this test is designed to compare the two cases in terms of the averages. And that is nothing, there's nothing beyond that, that you get from this result. So it's either you rejecting this claim or not. And I think that is what we said, Othello, that the p-value generated here is 29%, which means that it is higher than 5%. Being higher than 5%, then we will not reject it. We only reject when the p-value is small. I think that, I don't know if that was a question, Othello?
Just saying that when we are saying that they both are performing equally, we are not seeing even a small variation. That's the question.
No. You can actually see, if you look at this, the female performance the performance of the female is what? 7.9, and the male is 8.1. Those are the mean scores that someone can observe. So if one is to go by that alone, those are the you will see there's some difference. But then the question is, in statistics, in hypothesis testing, then this small gap, for those errors you are seeing, that yes, you rightly put there, they are not different significantly. They do not show significant deviation. So what can you will ask? Yeah. So if you do not do hypothesis testing, it is very likely that you will conclude that the males perform better than what? The females, because the average is higher. This is now on the descriptives. It ends there. But you see, you will give a false impression to somebody interpreting and say, indeed, we need to do something so that we can boost the performance of the females to match that of the males. While in actual fact, in statistical terms, that difference is not significant. So you can actually give a false conclusion based on descriptives only. But you see, the higher level can give you a different meaning altogether. Perfect. So I would like you to continue the discussion at your own, you have groups. meet at your own time or interact with this software at your own time. Play around with the other things I've even proposed in the handout, which is here. So this handout, I've done the first two. One sample t-test, two group, the context why we use it, and the interpretation. You can as well do the others, huh? Not all of them, but some of them, including this one for unpaired and the rest, as part of maybe a recap for the lesson. And then we will come and perhaps next week we will now give it more focus again. Having seen it for the first time for most of you, I'd like you to interrogate the document and this resource again. In closing, let's save the results. Yes, Josephine. Is Josephine's hand up?
Sorry for the interruption.
Correct, yes.
Maybe for the future, if you could just find out for us how to erase, because our laptops are not accepting the erase.
Or is that for the what do you call the MacBook? Is that what you're saying?
Yeah.
Okay, all right. I will try to do my research and then see if it's possible. Yeah. Unfortunately, the one that I sourced and got from somewhere is just Windows enabled. I'll see. But that is Josephine, Amisi, and Cindy. Those are the people that I've picked so far. Okay, right. Thank you. I want you to save this work by going to File, Save As, the usual way you save documents. Go to the same directory, give it a name. I've just given it any name. I've called mine today. Just save the way you normally save documents. Yeah. Have you saved your work? Hello, have you saved it?
Secretary, can this remain there so that we can try saving it after class?
You come back again?
I'm saying, is it going to be there after we close the class so that we can save it if you're not able to save right now?
These things. Whatever.
Yes.
What are these things? The ones we've been doing.
Yes.
That's why we are in the process of saving so that you don't lose some of the things. Yeah.
Okay.
So if you save the way I've given here, what happens is that you will only save the data, unfortunately. The way Stata operates, when I click save the way I did here, what you're only saving is the data. It does not save the commands. It does not save the results here. Now, but what we have done here is this can also be saved. One, the results in here, the one I'm highlighting, it was automatically saved in the work that we started earlier, the preliminaries, where we said results. These things are saved except the graph. So if you're doing a graph in Stata, you must save it separately if you wanted to use it. I think I have to make that clear. Any graphs are not saved automatically, but all these numbers are saved. The other things that are not going to be saved are these commands. But what you need to do is you save them separately. You save them separately in something called a do file. Do file is this icon you see here. It's saying new do file. Don't click it, but I'm just pointing it to you that those commands are saved in this do file. But what you need to do is you just highlight all of them. What you need to do, highlight all the commands. How do you highlight? By just click one of them and then Control A, or just Control A in your from your keyboard. Control A, or select all. Have you highlighted all of them? Once you select all of them, right-click inside Once you right click inside, you say send them to a do file editor. It will send it to an editor, a do file editor. If I click on it, you will see it being saved here. So this editor is open automatically, and it now neatly saves all your commands. Whatever you see in blue are commands. In red are these preliminary steps in savings. Anything in black are your data. So, okay. So having done that, you now go and save. File, save. You now save from here. Save as. You go to the same folder, give a name. You can say my do file. Okay. You are saving them separately. So there are things that will happen, and as you close, you don't just close data and you go home. If you want to use this later, the beauty with it is that you will not lose this, because you can run these codes anytime in any data in any time you want to use it. So even if I'm to close data completely, I'm saved now. So let me then close everything, including this entire thing. So what happens is you can now go to your folder and you find those things here. Your folder has the do file, which you can double click, and you have the commands there. This one is this is your data, or rather the data in Stata. If you double click, it will not open. You must open first Stata and then you open it inside Stata. This one you can't double click and open. For example, if I double click on it, it will ask you this thing. So you don't open directly this one. But the interesting one is the one for results. If I click results, this is where you find all the things we were doing. All of them are here because we had created them. So that's the beauty of saving your results separately before you do anything else. Fine. Anything up to there? That's a good ramp of introduction to Stata, and helps you to figure out how you can move next. Done. It's 8:40. I think we've exceeded our time. I would like you to, when the recording is up, you can just follow the discussion again before we meet next week. It's important that you can do another recap before we meet, and master the art of analysis of data, because when you go to the field, we don't want people that will go and hire statisticians. Yes, they lose out on the skill. You have a free software, you can use it for live, make use of it. If you have alternative software, well and good.
Jerry, I have a question.
Yes, Chris.
So is this a compulsory thing that one has to do in the thesis process? That is question number one. Number two, question number two, in applying, rather using meta-analysis method of research, does this apply? Thank you.
Oh, no. Okay. I think my answers are no in each case. But I want to be careful on the first one. Remember, we are learning skills in different contexts. You don't have to go this direction in terms of your research. It depends on your research question. Why I introduce this is because I've seen in the past some researchers which are largely descriptive statistics, but the researchers are not able to utilize an additional feature like what we've done today to test hypothesis. In some objectives, you're answering part of the objective. What is your objectives in your study? An objective would be you want to compare the performance of males and females students. So it's easy to just look at the summary and then say the males are perform better than the other ones. Or you want to ask whether you want to maybe assess the level of the preference of adult education in the region. So that's a good objective. You want to analyze or rather describe the extent or prevalence of certain variable in a region. So you can go and ask people what they've been doing. They give you all these narratives, but then you can be a bit clever and say, hey, I can actually demarcate my region into sections. And then I want to say, even though I've gotten the bigger picture, can I be able to confirm that there are certain differences, significant differences within the same group? So it is not a must to use, but it's a tool that you can explore. For meta-analysis, my knowledge in the same, I'm not an expert in meta-analysis, but that is a different software altogether. That's a different technique altogether. They are not related to this.
What about in mixed methods?
All right, mixed methods. Where is mixed methods? Have you explored the differences between meta and mixed? I think that is something let's not answer that now, because I think under research, the mixed method is a bigger family of methods that cut across both qual and quant. And within each, there are various methods. When you do meta-analysis, what are we talking about in here? Are we collecting key papers, trying to find out common themes, and then try to filter through to get out maybe the general picture or scenarios? My assumption is something related to that. It could be even numbers, it could be anything. So it's still operating under mixed methods. But what I'm saying, mixed method is very broad. It cuts across different techniques. So one of them is the meta-analysis, where you can just look at papers and maybe look at common themes and the rest and then filter through. But that should not, it should not be confused with what we're doing in this lesson. Okay? Because in this lesson, we're just providing aspects of things that can spice up your objectives. Okay. So let's take that discussion maybe on another forum. Chris, hopefully you could also explore it further in your research as well. I know meta-analysis is not very commonly used. That's why there's that kind of popularization across board. It's an area to explore, but remember that there is a technique, it's a different technique. Even the software you use, Stata 11 cannot do that. Possibly you need another higher version of Stata. I think Stata 16 or something like that. Yeah, it's a different technique. Good. Let me allow that we leave here. It's almost 9 o'clock. You have work to do. We will continue exploring. Good.
Thank you.
Anything else? I want to wish you a good night. We engage again next week.
Thank you.
Good night.
Good night, everyone.
Good night.